Ideally, when MOSFET enters into saturation region, we expect the drain current to remain constant, but it is observed practically that the current still increases, but the rate of increment is small compared to the triode region. This effect is referred as channel length modulation, which occurs predominantly in enhancement type MOSFET. This is similar to the early effect of BJT. Also, the tip of the triangular inversion channel begins to move away from the drain as we keep increasing the drain to source voltage after the MOSFET has already entered into saturation region. This happens because the depletion region at the drain terminal extends laterally into the channel, reducing the effective channel length. Since the drain current is inversely proportional to the channel length, we can write actual drain current is equal to channel length at threshold voltage divided by reduced channel length in saturation region into ideal drain current. We also have modified formula for drain current in saturation region, which is equal to ideal drain current into 1 plus lambda into drain to source voltage, where lambda is referred as channel length modulation constant. We can plot the drain characteristics graph taking n channel MOSFET into consideration. The dashed line represents the ideal graph, which will be the constant ideal drain current, and the solid line represents the practical graph considering channel length modulation. If we talk about channel length modulation constant, then we can find its value by using this graph only. We have to extend the graph of practical case and mark the voltage where the extended line cuts the x-axis. Let it be equal to negative of VA. Channel length modulation constant will then be equal to 1 upon VA. Also, this voltage value is actually directly proportional to channel length. We can modify this relation into an equation by introducing another constant. You will be studying different models of MOSFET in analog electronics. There is one parameter which is very important, referred as output resistance. Output resistance R0 is defined as differential of drain to source voltage with the actual drain current. The output resistance can be approximated to be equal to 1 upon channel length modulation constant into ideal drain current. This parameter may not be very useful in electronic devices and circuits, but is very important in analog electronics. Now consider the graph once again. We will summarize few concepts in this particular graph. This region will be considered as triode region. This region will be considered as saturation region. Now, can you think where will be the cutoff region? The only point which can be said to be in cutoff region is the origin. Remember, MOSFET is a symmetrical device. When we apply a negative drain to source voltage, then the roles of drain and source will reverse, but there is no need to draw that. Just keep this in mind. The graph exists only in first quadrant. I am just writing symmetrical just to signify that we have considered only positive drain to source voltages. We can also plot transfer characteristics graph, which is the graph of gate to source voltage with drain current keeping drain to source voltage constant. Here in this graph, there is a significant portion which is in cutoff region. This will be the cutoff region, this will be the saturation region, and this will be the triode region. This graph is actually the ideal graph. In the coming lectures, we will see the real or practical transfer characteristics graph. Now try to solve a very simple question. Pause the video and take about 1 minute to solve this question. Now cross-check your answer with the solution.